Started.
All right, welcome back from the break. Let's talk about test-driven development. That's what we're going to cover today. Everything that you're seeing here is also, everything that you can see me type today is basically directly copied and pasted from the curriculum, so you can follow along over there. What we're going to do here is we're going to introduce a concept called test-driven development. And since I picked on Jared, and Jared is my volunteer for right now, Jared, have you heard of test-driven development? And if you have, tell me a little bit about what you know about it.
Yeah, so test-driven development is making a test before you build whatever you're trying to code, so that while you're building whatever you're making, you can see if it's working or how far it's come along.
Cool. Did Jared cut out for a lot of people, or is it just me?
It cut out for me.
Yeah, all right, Jared, you cut out for me, but everything you said, I kind of got as you were saying it. You're right. It's basically it's the decision to write tests ahead of time before you write any sort of code. And this helps you in many ways. You can pseudo code things, you can do test-driven development. It's somewhat similar, but test-driven development, again, I'm writing the tests ahead of time. So I'm thinking through all of the edge cases, like what's my code supposed to do? And when you as a developer are forced to think through your entire program and what your program's supposed to do prior to actually writing the code, it makes sure that whatever code that you actually write does work, and you can account for all the edge cases. And in the future, in the case that you decided to edit any sort of code and you want to update it, it won't, basically whatever you update has to pass the test, which is supposed to, those tests basically show this is what my code and my program is supposed to do ahead of time. So what we've been doing so far is we've been writing code inside of here, let's see, factorial spec, you all can see this. We've just been writing what's called driver code. We're gonna have a bunch of true statements, and it's fine. It's not great, but it is fine. What we're gonna use today is something called unit test. That's something that's built into Python. So to do that, we're going to do a challenge called Fizzbuzz. And according to a website, let me just check what's the exact number, Fizzbuzz prompt. Okay, so according to this website, it helps filter out 99.5% of programming job candidates. I don't know how accurate this actually is, but seeing as there are a lot of web development and software engineering jobs out there, it probably does. Let's read through this problem together. All right, so what we're gonna do is we're gonna write a program. It's gonna print the numbers from 1 to 100. But for multiples of 3, we're gonna print fizz instead of the number. For multiples of 5, we're gonna print buzz instead of the number. And for multiples of 3 and 5, we're gonna print Fizzbuzz. Evidently, 99.5% of people can't solve this, so we're gonna become part of the 0.5% that can. Let me just grab this, jump back over here, and let's create a Fizzbuzz. Let's just start writing some code. Let's list out everything. We don't have a Fizzbuzz folder. So Jared, are you still there?
Yeah, I'm still here.
Cool. Tell me how do I create a folder and go from where I currently am into that folder?
So you can write mkdir and then a folder name.
And I'm going to call it Fizzbuzz.
Then you can cd into that folder.
Yep. So I created a folder called Fizzbuzz, and I changed directory. So I double clicked from where I am into the folder called Fizzbuzz. Let me open this up inside of let me restart VS Code. And let me do a couple things. I want to create 2 files. One of them is going to be fizzbuzz.py, and the other one's going to be fizzbuzzspec.py. How do I do that?
You can touch,
Yep.
and then the file name .py.
Fizzbuzz.py, and I can create another one called fizzbuzz, and you'll see it show up on the left side. Fizzbuzz and fizzbuzzspec. If you want to be lazy and not learn this stuff, which I highly recommend, you can also just press this little button here for a new file. I'm going to open up these 2, and I'm going to just be looking at the spec file for right now because we're doing test-driven development. I'm going to write again, keep this up here, write a program that prints the numbers from 1 to 100. For multiples of 3, print fizz instead of the number. For multiples of 5, print buzz. And for multiples of 3 and 5 per Fizzbuzz. So what do we know about this? Like the program that we're about to write, what are the big things that we know? I would argue that number one, it should return a list because it returns the numbers from 1 to 100. The list that it returns should have 100 things inside of it. And the elements should look like 1, 2, fizz, 4, buzz, and then continuing on all the way until 100. So I'm going to do a lot of copy pasta over here, and let's take a look at what we've got. This is directly from your curriculum for today. Let's read line by line. Number one, import unit test. What does this do? It just imports the unit test library. This is built into Python 3, and basically whenever you want to bring in an external library, something that's not built into like core Python, we have to import it at the very top. So that's what we're doing here. We're going to import unit test because we're going to reference it here on line number 6. This won't make any sense, but Fizzbuzz test case is inheriting from the unit test library, specifically the test case module. If that makes sense to you, great. If it doesn't, that's okay. We're going to cover that next week. And then on line number 4, it says from Fizzbuzz, import Fizzbuzz. This is kind of strange, but this is saying from the Fizzbuzz file over here, import the Fizzbuzz method. We don't have anything in there quite yet. Let me split right so that we can see this more easily. I'll drag this over. So from the Fizzbuzz file, import the Fizzbuzz method. We haven't done that yet, but we will very soon. And we're just going to run each test case. These 3 double quotations is basically just a comment for you to read. These are tests for fizzbuzz.py. The first test is going to be, it returns a list. And this is a little bit, again, for the developer to read. When you call Fizzbuzz and you invoke it, you should get a list back. And we're just going to assert equal that whenever I call the type of Fizzbuzz, it's going to equal a list. A couple things to note about unit tests. It looks a little bit foreign. This is just a library within Python. Every single test must start with the word test underscore, otherwise it doesn't run. So every single test, again, has to have test underscore at the very beginning. What I'm doing here is I'm asserting that these 2 values are equal. The assert equal is one of many different assertion statements. There are much more inside of the curriculum. It's a link in like the second paragraph after this code block that I copy and pasted. So assert equal is just one of many different assert statements that you can say. So I've got type Fizzbuzz. What I'm doing here is I'm invoking the Fizzbuzz method. As a result of that, I'm going to say what is the type of the output of the Fizzbuzz method. That should be a list over here. All right, let's start writing some code. I've got, again, I'm just writing tests to make this pass for right now. So def Fizzbuzz, and I'm just going to return an array. That's it. Very simple. Let's see if this works. Inside of your code, inside of your machines, if you want to follow along right here, what you're going to do is you are going to run pip install green. And this is what this is doing is pip is basically saying, look, hey, there is a library called pip. It installs other libraries and manages versions of Python libraries for you. Install something called green. If I hit enter here, it'll run all the way through. I've already satisfied this requirement. If this doesn't work for you, type in pip3 install green. And what I'm going to do is instead of writing Python Fizzbuzz spec, which I totally could, when I run this, it's kind of nice to see, but there's no colors. And I would prefer to see a little bit of color here. So I'm going to run green Fizzbuzz spec.py. And right now what's going to happen is before it was just black, now it just turns green, and I got a green OK. It's just a little bit easier for me to read. So we've got this here. Test returns a list. When you call Fizzbuzz and you invoke it, you should get a list back. This Fizzbuzz, again, comes from line number 4. It's saying from the Fizzbuzz file, on the top left here, import the Fizzbuzz method. Cool. So I think that's cool. We've got it returns a list. What's the second thing that we said about this one? So we said for this program, it's going to return a list. the list is going to be 100 elements long. So with that, let's try typing this one out. I'm not going to copy paste. Def test underscore. I know that for all unit tests, I need that. It returns a list of 100 elements. All right, and I'm just going to write a little thing for myself. When you call Fizzbuzz, you should get a list of 100 elements back. Just a little note for myself. So same thing as before, self.assert equal. You can kind of see there's a ton of different assertion statements you can make. For right now, I'm just going to say assert equal. I'm going to do the length of the output of Fizzbuzz is going to equal 100. Again, I wrote my test case. It's prepended with the word test underscore. When it returns a list of 100 elements. When I call the length of the output of Fizzbuzz, that should equal 100. So if I run this one more time, this is where the green comes into handy. What you'll notice is that I get a very violent output. The first one is green. That's this first test that I wrote over here. This when you call Fizzbuzz, it returns a list. But the second one blows up, and it tells me exactly where it blows up. All right, it says it blows up over here because 0 does not equal 100. Let me scroll down a little bit. Fizzbuzz over here should be 100, but the output of Fizzbuzz is 0 because, look what I'm doing, I'm just returning an empty list here. So I can change that one real quick by doing a times 100. Let me just jump into Python to show you why that is. If I do a times 100, I will get 100 A's inside of a list. Running through this one more time. Before you saw that there were 2 tests. There was 1 failure and 1 passing. If I run it one more time, it will have 2 passing things. But again, this is not really testing exactly what I want. I know that in the end, I want it to return 1, 2, fizz, 4, buzz, and so on and so forth. So I'm just testing. It returns a list of 100 elements. And I'm going to type in one more thing, which is def tests returns the correct 100 elements. Something like this. And I'm going to add in my little code here. Oh, some small tricks. Click in the middle of any line inside of VS Code, Command C, and then you can Command V the entire line, so you don't have to highlight everything. I am going to say self.assert equal. When I call Fizzbuzz, the output should be the expected output. So I'm just going to exit this expected output. I'm going to say expected output is equal to, and I have the answer over here inside of the write-up. Let's grab that and pull it back over here. This is what I expect the output to be. 1, 2, fizz, because again, 3 is evenly divisible by 3. 4, buzz, 5 is evenly divisible by 5, and it continues all the way here. So I've got this all for you, and I've got the expected output. So what I'm saying is when I call Fizzbuzz, the output of that should equal the expected output, which is set over here. Run the test one more time. Obviously, I will have 2 passing tests and 1 failing test because the first one, A, does not equal 1. So the moment something blows up like that, it's gonna blow up. Let's talk about this. I'm gonna pull it over here, and let's write some pseudo code. All right. So let's say pseudo code. And then Jared, I'll come back to you, I promise. I'm just trying to power through this right now. Write a program that prints the numbers from 1 to 100. For multiples of 3, print fizz. Multiples of 5, print buzz. For multiples that are 3 and 5, print fizz buzz. So number 1, write a method called Fizzbuzz. Fizzbuzz takes no arguments. Number 2, maybe you want to create an output list array, because I'm going to create a list of elements. I'm going to keep shoving stuff inside of that. Iterate from, sorry about the background noise. I do live in the city. iterate from the numbers from 1 to 100, maybe 3a. If iterate from 1 to 100, keep track of the number as number. And you'll notice some things are uppercase and some things are lowercase. I'll get to that in just a second. If number is evenly divisible by 3, push fizz into the output. 3b, if number, actually I could just copy this because there's a few things that change. So grab this, copy it twice, and move it on here. If number is evenly divisible by 5, push buzz into the output, and then 3c. If number is evenly divisible by 3 and 5, push Fizzbuzz into the output. And then it seems like for everything else, you just put the number in. So I'm just going to do 3D, else push number into output. And then number 4 down here, return output. What you'll notice about my pseudocode is I've done this a lot of times, so I can like power through this pretty quickly. But the thought here is I want to think through everything as much as I can beforehand. And I want this to be as detailed as possible. And anything that revolves maybe around code, I'm going to do in uppercase. So all my variable names are all uppercase. And what you'll notice is when I create an output array, I'm going to shove it into output. It's easier to find when it's all uppercase because it looks a little out of place. And you'll notice that these are all the same thing. Like when I create my output array, I'm going to shove fizz into the output. So it's going to be easier for me to translate a little bit later. Let's try this one out. Jarrett, are you ready to help me out here? Because I don't really know what I'm doing when it comes to coding.
Yes. So,
did I do this correctly?
yes.
Cool. Number 2, create an output array. Tell me what to type.
You can put fizzbuzz underscore list equals 2 empty brackets.
Yep, that's one way of going about it. Let me just change all of these because I originally had it as output. But
yeah, you can put it as output.
Do fizzbuzz list. How did I do this magical multi-cursor thing? I double-clicked on something, and every other time that it shows up, it'll kind of highlight. I can do Command D to highlight a bunch of them. Now I have multiple cursors at one time. Small little things. Cool. Again, double click on the thing that you want to highlight, Command D a bunch of times, and you got it. All right, so Jarrett got me through number 2. Iterate from 1 to 100. Keep track of number as number, like a thing that you're currently on. Tell me what to do.
You can make a counter, set it equal to 0.
Okay, we can do a counter. We can do, yeah, well, let's do that. Counter equals 0. Go ahead.
For I in range of 1 to 101.
Do I need a counter?
Oh, no, you don't need a counter.
Nope. All right, so I'm going to iterate from 1 to 100, keep track of the number as number. Let me just change I to number, just to make it a little bit more readable. This range over here, tell me a little bit about what's going on there.
So range makes an array from the first number you give it to the last number, but not inclusive to that last number.
Yep, that's right. So range creates an array. It's going to start at this number, the first number that you provide, and it's going to go up to, but not including this number. So it's 1 less than this number. That's why it's 101 instead of 100. All right, so you are keeping track of this as number, and now we get to go through all of this stuff. Tell me what to type.
If number modulo 3 is equal to 0, push fizz to fizzbuzz list.
Cool. I don't know how to do that.
Oh, just type fizzbuzz list dot append.
Cool. And you'll kind of see, like, as Jarrett's talking, all of the stuff that we're typing is directly from this list of pseudocode that's happening over here. And just for time's sake, I'm going to power through the next bits. And then at the very end, I'm going to return this Fizzbuzz list. I'm going to change a few things. 5. I think this first one was
Fizz.
Yep. And then the last one is Fizzbuzz. LF, it's 3 and 5, right?
Yes.
Let me move this over a little bit so you can see a little bit more. Fizzbuzz, otherwise. All right, let's take a look and let's see if it matches up with my pseudocode. Number 1, write a method called Fizzbuzz. It takes no arguments. Number 2, create a Fizzbuzz array. Cool, it's empty. Iterate from the numbers 1 through 100. Keep track of each number as number. For number in range of 1 to 101, from 1 to 100. If the number is evenly divisible by 3, append fizz. If it's evenly divisible by 5, put buzz. Fizz 3 and 5, put Fizzbuzz. Otherwise, just put the number and then return the list. I feel pretty good about this. Let's run it. I'm going to clear the screen, and I'm just going to run green Fizzbuzz spec so that I get like very, very loud colors. Oh man, I don't know what's broken. Oh, jeez. Jarrett, help me. I don't know what's going on.
Well, you can look at the up arrow, and it says ELIIF. So
yep. Maybe I should
one
just
more I.
Line 18. It says there's invalid syntax, and it points to exactly what's wrong. Oh, it looks like I've got 2 I's. These messages here are here to help you. Run it one more time. I got 3 failures. I got the first differing element is that element number 14. Number 14 of an array is the 15th thing that you'll actually see. It looks like I got fizz instead of Fizzbuzz. So when I got to 15, it ran through all this code and then it appended buzz instead of Fizzbuzz. So how do I fix that?
You can move the number modulo 3 and number modulo 5 as the first if statement.
Yep. This magic thing I'm doing again, I'm just highlighting 2 lines. I'm going to do Command, Control, and press up to move blocks of code up at a time. Helps out quite a bit. So according to Jarrett, which I agree with, I'm going to move the most restrictive thing at the very top. Because what was happening a little bit earlier, if I go back to it, when 15 comes through, 15 is evenly divisible by 5. So this hits before here. And because this is less restrictive than this over here, once it gets to this point, line number 18 and 19, it just moves on to number 16 after that. It never even hits this at all. So you want to have the most restrictive if statement at the very top. I'm going to edit this over here. If I try to run this one more time, now I have 3 passing things. One thing I might do to make this a little better is anything evenly divisible by 3 and 5 is also evenly divisible by 15, just to make it a little bit less verbose. Let's run it one more time. Again, this is the power of writing your tests ahead of time. When you write out all your tests like this, anytime that you change something, you know it's not acting like the way that you want. 3 tests, 3 green dots. It says okay, 3 passes, and we're good to go. All right, how are we doing on time? I have 40 minutes to go through Roman numerals and to go through a beyond set. All right, I will take that as a personal challenge. Let's run through Roman numerals.